Hello students, good evening. This is Jagan Babu, Assistant Professor, Department of ECE, RMD Engineering College, Autonomous Institution, Kavarapete. I am going to give a video lecture, the subject 2.1 EC 601 Discrete Time Signal Processing. This is also called as DSP subject. In this I am going to concentrate unit number 4. Compared to all the units, student felt easy and simple and flexibility unit is unit number 4. The unit number 4 is called as finite word length effects. In short form we used to call this FWL, finite word length. Once analog signal is converted to digital signal, we need transformation, unit number 1. Once it's converted, all the analogs are to be changed to digital, we need filters. That is unit 2 and 3, FIR filter and IR filters. Once we converted into analog to digital filter, we need to see the output in finite word length. That is the 4th unit, FWL. What are the effects we have? The main effect is noise, error, quantization. These are the 3 effects. Okay. The prerequisite of this subject is, this unit is signals and system, especially transformation topics, mathematics. The application is default mobile and satellite antenna propagations. What is the objective of this unit? To know about the effect of finite word length in digital filter in terms of 3 main causes. The first main cause is quantization, the second main cause is error, and third main cause is noise. Okay, we'll move to the topic. We'll give the flow diagram of the finite word length effects. Okay, the first flow diagram case, input case, analog or continuous time signal. We simply called as x of t or called as xa of t or xn of t. It may be a signal, voice, speech, data, information, etc. Now it's going to convert analog or digital. So that is called C bar D. It may be a conversion process, either continuous C or discrete D. So first the input is analog or continuous signal. I am taking as a signal called as XA of t. I am taking the signal is called XA of t. After this, it can be changed into a continuous and discrete time, C bar D. This any signal going to be changed in terms of continuous signal as well as a discrete signal. Once it continuously changed or discretely changed, now this XA of t now becomes to the XN. It's called as a discrete wave. Okay. Once we completed this analog signal, then we completed the continuous and discrete time signal from XA of t to the X of n. Next we move to the quantizer. Now X of n input to be changed as X bar of n through XQ of n. We have 3 cases here. I clearly explain. X of n discrete signal changed into the digital signal X bar of n through the XQ of n. What is XQ of n? Which is called as quantizer. Okay. So X of n discrete through the quantizer, which is called this is called a step size, the range of the quantization. The sampling techniques will be appear here. The samples will be splitted into the segments and segment and segment and segment. It is called quantizing. The quantizing is something where the sampled signal has to be checked whether the original sample will be equal to the output sample or output signal through quantization. That is called quantizer. Here we have discrete input, digital output X of n to be X bar of n through the quantizer output or quantizer input XQ of n through XQ bar of n. Once quantizer process over, we have next heading is encoder. We want to get the output through encoding. There are n number of encoding techniques are there. I think you have been studying the digital communication subject. Here bits, B represents bits per samples. Now for this encoder, the input is digital input X bar of n. Through X bar of n, my bits are encoding to error E of n, output error. Okay. Once all the digital signals are converted through the error signals, this error signal is called as error or noise through the quantization. And that's why I said now the original sample will be 0.75, the quantized will be 0.70. In between we have the error called 0.05. Okay, so through we check with the bit samples through encoding technique. After this error, we have the output called as 0, 1, 0, 1, 0, 1, 0, 1s. Here we are going to limit this, that is called finite word fx. This is the basic block diagram of the finite word length fx. Then we have the topic called quantization. There are three types of quantization: input error, coefficient error, product error. Then we have the two types of quantization noise, that is called truncation as well as the rounding. Then we have the overflow error through saturation arithmetic and signal scaling. Thank you, students.